Hello, everyone. Thank you for attending today's webinar, How to Build a CBRS Network and Transform Industry, presented by Cambridge Consultants and Geoverse. My name is Andrea Anderson, and I'll be moderating this webinar. Our speakers today are Jacob Reed, VP of Wireless and Digital Services, Cambridge Consultants, Colin Campbell, VP Engineering, Cambridge Consultants, Scott F. Young, COO, Sentry Financial, Rod Nelson, CEO, Geoverse. You can read our speakers' full bios on the left side of your window by selecting the Speakers tab. Just a few technical notes before we begin. If you'd like to download the slide deck, please click the Handouts tab button on the left side of your screen. Also, the webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your volume is up. This webinar is being recorded and will be available on demand within 24 hours after the event. Time permitting, we will follow the presentations with a Q&A session. Please submit your questions using the Questions and Answer tab on the left side of your screen. Okay, now let's begin. Jacob, please go ahead.
Hi, I want to thank everybody for taking the time today to join us for this webinar. Again, I'm Jacob Reed, VP of Business Development for Cambridge Consultants based out of Minneapolis, Minnesota. The backdrop of this is CBRS and, of course, private cellular networking and the pent-up demand, or what we're actually seeing in the industry itself. I think a lot of people understand the fact that, $4.6 billion is spent on that spectrum as it relates to the primary access licensing. And what's really unique for us and what you've seen is that a lot of the companies that actually bid and won that spectrum are not your prototypical operators and et cetera. And what this really truly shows is that companies in warehousing, companies like utilities are really looking at what they can accomplish by owning a network and owning that track record as it relates to building that network. As well as kind of building out their own nodes and finding a way to own their own data. These are all things that are kind of what we've seen as it relates to the network itself. So where does Cambridge kind of fit in all this? Well, Cambridge itself, to give background, a lot of people potentially don't know who we are, is the innovation arm for numerous companies. We've been able to help companies in such like taking RF and putting it into public facilities, and allowing visually impaired and blind people to have a digital eye, to helping a satellite operator build the world's largest and first push-to-talk network, to most recently building an antenna array that will allow to bring 5G to the world via the stratosphere. You don't do this without having years of experience and the personnel to do such. As you can see from our slide, the amount of people that we have on our team, and a majority of them being engineers, designers, and scientists, with specific skills to help in that innovation role and goal, and as well as the facilities. On top of it all, having a background or being owned by a company, Capgemini, gives us an opportunity to really help our customers and clients go after their innovation goals. So industries are facing extraordinary change today, and that's not any different than what we're seeing here for CBRS or private cellular networking, right? So innovation is not only a goal, but a requirement. And that as well is in the world that we're talking about. And in a lot of this, companies are looking at what they can do and how they can actually build a network as well as their nodes to their specific solutions. And what that means is that, customizability and innovation are one and the same. This is where we're really seeing connectivity in Industry 4.0 kind of collide together, where organizations are building specific networks to meet their needs, but as well as building nodes and et cetera, from AI to edge compute within their solutions to allow the organization to grow. And then more importantly, scale beyond what they currently have today, which is really what kind of transpires and doesn't happen when you start to build off custom commercial off-the-shelf solutions. And in essence, almost building what you currently have today within the MNO network, which again is a major reason why these companies are looking to innovate and kind of own their own network and subsidize what's happening within their facilities. So what we'd like to do here is kind of, dive into some of the experience we have from the technical learnings. And what I would like to do is turn this over to Colin Campbell to give him an opportunity to kind of go through some of the case studies and the challenges that we've seen in the space and how we've approached it. Colin?
Thanks, Jake. So I'm Colin Campbell. I'm VP Engineering at Cambridge Consultants. I lead the US side of our development organization. I'm based in Boston. So as Jake mentioned earlier, CBRS is something that's really exciting for us because we're starting to see more of the typical clients that we work with, the non-network operators who are looking to create their own private networks. We've been doing this for people for a long time, long before it was actually a popular thing to be done. And so we've had kind of reasonable insight into what people are trying to achieve and why they want to achieve, and even more importantly, how that can be achieved. So apart from the kind of commercial driver that is CBRS, there's some other trends that we're seeing that are starting to make these kind of private networks, customized private networks, really possible for people nowadays. And the biggest one of those really is that wireless networks are looking like distributed data centers. And by that, I mean that much like a data center, the hardware and the software are completely disaggregated. They run at their own timescales of evolution and innovation. The network is defined mostly by the software running on commodity hardware right up to the edge. Now, there's very little specific hardware designed just for the network, certainly as we see going forward. So what that means is that much like in the data center space, where innovation is in the software, where people can use a lot of commodity software, but then create their own unique services by specializing just the bits of software that really matter for them. I think we've all got personal experience in that, and when we're using apps on our phone, there's a lot of plumbing under the hood that is the same software, the same hardware running unique applications that deliver different benefits for us as a user. And the same trend is true in wireless networks. When you're looking at what do you want to achieve with your wireless network? Another side of that is 5G is one of those very much software defined technologies. It has the flexibility built in to be able to tune and customize that network to really target the specific requirements that you're looking for. And when we're talking about those kinds of requirements, the challenges are actually really difficult to meet. Because it's a wireless network, you can't just put in another 1,000 nodes and expect 1,000 times the performance. It just doesn't work like that. There's inconveniently physics gets in the way. But you do have control over some parameters. The normal ones that you're looking at is range, is throughput, is capacity, connection density, latency, reliability. These are all parameters that you can tune to meet your particular application. It's a bit like squeezing a balloon. You can't squeeze them all down, but you can choose which ones where you're going to compromise. When you look at modern standards like 5G, they've attempted to do this in some ways. If you look at the 5G triangle, the kind of three corners of that triangle are trying to target different use cases within that parameter space. But that's not the end of it, because as a standard, it's trying to cater to as many possible applications as possible. And yet your particular application is unique. So you can customize, but you really need to customize to what you are trying to achieve. So to try and ground it down a little bit into sort of actual examples, I'll just go through a couple of high-level use cases that we've come across in our past. So fairly common use cases, automated warehousing, where you're looking at trying to automate a business process to get the efficiencies through, but using what we're calling a centralized brain, so something in the middle that is making decisions to try and optimize the flow of goods through your warehouse. One particular challenge, possibly not the only one, but one particular challenge there is extremely high connection density. If you can cast your mind back or forward, depending on which way you want to look to, the time when you were able to go to your favorite football stadium and watch a game and sit around with thousands of people in a very constrained space. If you imagine all of those people trying to make a phone call at exactly the same time, it's a very low percentage of those calls will actually get through. In a warehouse setting or an automation setting, every single one of those has to succeed. You can't build a business around the probability that something might not get through. So what you can do, though, is design the network. So designing predictability and designing the redundancy in nodes to increase the density, but also at a fundamental level, look at where the intelligence actually is, and understanding the information flows and data flows that you want to achieve, and how you can best use the network to achieve that. Another example, which has similar properties, but in this case, rather than being constrained into a small warehouse, relatively small, a much larger kind of field that you need to cover in geographic areas when you're looking to monitor and control remote assets. Those monitoring those remote assets have sensors, lots of data flowing back into the network. So you've got to achieve a high capacity in a limited region, well, in a large region, but with limited resources. Most likely you've got very low capacity backhaul. These remote nodes won't be able to connect back into the internet to transfer all the data back to a central server to then be able to make decisions on that to go back into the field. So looking at the way in which you can work around that is making sure, moving more intelligence to the edge. So using the fact that the hardware is capable, you are capable of running automation or intelligence type tasks, AI type tasks on the same hardware that is running your network. You can use smart antennas to direct the coverage so that if you were trying to monitor a pipeline, you can try and make sure that the coverage only affects that pipeline, and you don't put coverage on areas that you really don't care about and you're wasting energy. And of course, these are continuously adapting. You need to continuously adapt because the environment's continuously adapting. You've got little control over the entire environment out there, so you need to monitor and adapt the network to meet its changing needs. Now, running through all the use cases that we see is intelligence. So the reason we're trying to connect is to get data, but fundamentally it's to do something with that data. It's to perceive the world and make those critical decisions. And particularly when you're looking at decisions that are timely and need to happen, with a kind of criticality, you want to be looking at, if you look at, say, for instance, robotic control, where you've got wireless sensors coming to a robot that has got to make autonomous decisions to do something based on the information it's getting from those sensors. One way in which you can make this happen is to look at the two together, co-design the wireless and AI systems, recognize where their weaknesses are, where their strengths are, and work together so that one is augmenting the other, and you're not constrained unnecessarily by choices made for one or other of those systems. Obviously, automating models to run at the edge is a significant factor in that. You don't have the opportunity to literally spin up as many GPUs as you like, as long as you can pay for it. You've got constrained resources, so your models need to run on the resources available. And a big challenge is training and adapting those models across a distributed network where you can't get the information everywhere. You can't get perfect information to every node in the network. So you need to be able to train your models so that they can all learn from each other throughout the network. So to just kind of bring it back together, I guess we're looking at, as I said before, we've been looking at these private networks for quite a long time now. We recognize the challenges. The challenges are there and real, but they can be overcome, and they can be overcome as long as you know what you're designing for and how you can pull the various levers that are available to you to get the right level of customization that meets your use case. So you can use this great sort of body of shared resources that everyone is benefiting from to then just customize the bits that matter to you to deliver the service that you want. And with that, I'll turn it back to Jake.
So thank you, Colin. So this slide, which I jokingly call it the NASCAR slide for a lot of organizations, and it's, from that standpoint of just kind of putting slides up or logos up and kind of showing maybe their partnerships. The reality of it is the customers that you see up here are clients of ours that we've created intellectual property and defendable positions within their organizations, and we're a trusted advisor to these companies to help them grow in the innovation space. But more specifically, as I move on to the next slide, I would like everybody to kind of walk away with an action here. And that action is go to our website, check out these case studies that we talk about 5G in the stratosphere and how we basically designed an antenna array that can cover hundreds of miles within the area, giving specific 5G coverage to those areas, which is very relevant to what you're trying to accomplish here in CBRS, to working with an organization that is an oil rig and being able to use a sensor, a node, a subsea sensor in this case, to monitor what's happening in the field. To helping companies like Okada, which created a smart platform, but ultimately working with us to change them from an online grocer to actually building that smart platform and taking and incorporating numerous aspects of what we talked about today, from the network itself to the nodes, to the robotics, the AIs, and the edge computes, to finally working with Iridium and helping them with their satellite network. So when you walk away today, definitely take and look at these case studies. And then from there, honestly, let's talk. Wherever you're at in your journey as it relates to this technology, you could be at the very beginning with some ideas. We can definitely engage and kind of help you out and give you some thought leadership. You could be at a point of doing a feasibility study, which we definitely can work with organizations and be technology agnostic and kind of give them a background on what areas they can improve on and maybe what consumer off-the-shelf solutions will work and which ones they can actually improve on. Or you could be down the line where you're at a 1.0, 2.0, or 3.0 within your solution, within your network, but you're kind of wondering, what can we do now? How do we move this forward? And that's where we can engage. So both Colin and I look forward to talking with you guys after this webinar and as well as answering your questions later today. At this point, I'd like to turn it over to Scott to kind of go into how to finance the development and the equipment as it relates to building a CBRS and private network. Scott?
Thank you, Jake and Colin. I appreciate the opportunity to participate in this panel discussion alongside of Cambridge and Geoverse. I am the Chief Operating Officer of Sentry Financial and a co-founder. My business partner and I founded Sentry Financial back in 1986. Prior to that, we were on the education and consulting side of the equipment finance industry. And we kind of discovered that doing deals and structuring financing to meet unique needs of customers, including financing private networks, is something that we're really good at. Since 1986, we have financed over $3.5 billion of equipment for our customers. And most of our financings are structured. And even in the private network industry, you have issues with, what gets included in the financing besides the hardware, or if there are deposits or progress payments that need to be paid up front. How do you build that into the financing to make it easy and convenient for the customer? We have focused on the telecom industry for the last couple of decades. We focus in other industries as well. And we team up with folks like Cambridge and other vendors, whether they're equipment manufacturers or they are a company like Cambridge, or they are an integrator of a system for a customer. And we team up with them to enable them to provide financing to their customers. To give you a sense of the financing market, 80+% of all U.S. companies utilize leasing to finance some aspects of their equipment. And in 2019, over $1 trillion of equipment and software was acquired through leasing and financing. So the point here is the market is huge. And with private networks, it is a CapEx expense that is unexpected for a lot of customers. And so being able to structure the financing as an OpEx expense is quite an advantage for a lot of customers. On this next slide, it kind of just shows how simple the process. The vendor, whether it's Cambridge or someone else, and their customer engage in discussions, and they lay out the extent, the nature, and all of the components of the network. And then we craft a financing option that makes it easy for the customer to finance the project and to get it and pay for it over time. We do not get terribly involved between the vendor and customer and their negotiations as to exactly what is entailed in the network, because that's not our expertise. Our expertise is to come up with a financing option for the customer that takes care of the design, the development, the installation, the hardware, and oftentimes, there is a maintenance program with like Geoverse. We might be able to include the first year or two of the kind of management fees. So, and it varies customer to customer as to whether they are looking for a financing in the 5, 6, 7 year time frame, or are looking for a financing of up to 10, maybe 12 years of financing. And from a customer perspective, the better their credit is, the more flexibility we have as far as to what is included in the financing and the time, the term of the financing. But once the vendor, Cambridge, and the customer agree on the private network and the customer agrees to the financing terms, once the network is installed and the customer is happy, the customer accepts the network and we pay Cambridge, and then the customer pays us over the term of the lease. It's a pretty simple process, and we do try to make it easy for our customers. On this next slide, it's just to kind of a list of reasons why customers look for financing. One of the critical ones is it's 100% financing typically. And we do try to include the design, the development, the software, the installation, all of the components of the complete system to make it easier for the customer. In today's environment, more so than pre-2020 and COVID, today's environment, a lot of companies, they're canceling their CapEx budgets or they're postponing them. Liquidity is tight. And so for a lot of your customers that are looking for a network or other equipment needs, they're going to have to look to lease financing and converting it more into an OpEx expense over a CapEx. But here are just some lists as to why customers choose financing. Most often it's CapEx versus OpEx. It's technological obsolescence, it's tax advantages, and other accounting issues. This list here is just some of the companies that we have provided financing to over the last 35 years. This one is, again, we focus primarily in the US and Canada, but we have financed equipment for our customers on virtually every continent across the globe. And so just to give you some background there, contact information, you can find us online. I'm happy to respond to any questions during this panel discussion or after if you want to reach out to me. Now I would like to turn this over to Rod Nelson of Geoverse.
Hi, good afternoon, everyone. Let me advance the slide here, I guess. Okay, so at Geoverse, we are a company that's both a cellular operator and a broadband operator, but we really focus on supporting customized solutions for enterprise customers as well as carriers. We've been doing that for a couple of decade history. In fact, today we're the largest neutral host operator in the United States and a leading provider of private cellular capabilities for enterprise as well. So we operate in three segments: private networks, which is focused mainly on enterprise customers; rural and a broadband segment, which provides broadband, both wireless and fiber-based, to consumers and enterprise in smaller markets; and then service provider solutions, which provides wholesale services to the tier one carriers. The unifying theme across those three segments is that Geoverse delivers essential connectivity to places where it otherwise wouldn't exist. And perhaps most important to this conversation, we have a well-developed network operations and customer support capability that's been developed by providing these service provider solutions over the years, which we now can apply to supporting private networks with our 24/7/365 network operations center and our customer care capability to support enterprise customers. At Geoverse, we have a core value proposition that centers around creating two sources of value from a private network investment. First, obviously, is the private network that's been designed, built, customized for high-performance, secure enterprise applications. But with Geoverse, we're able to also add a neutral host capability to that, which means that we're able to have the customers from the tier one operators get support from these private networks as well. And what this opens up is the potential for more interesting business models and ways that enterprise can get value from the investment in a private network. And to do that, we've developed a couple of technology platforms at Geoverse, which we call GeoCore and GeoTrade. But before going deeper into that, I'd like to just come back and touch on the really profound disruption and innovation that's enabled by the CBRS spectrum. I spent a good portion of my career at AT&T Wireless in various technology positions there, and this cellular networks have always been the provenance of large operators up until this point. But with the advent of CBRS, whether it's the generally available or the priority access licenses, we now have the spectrum that's designed for cellular that can allow you to bring the advantages and the performance benefits that cellular technology can have, and you operate that alongside of your enterprise Wi-Fi networks, for example. We have 150 megahertz of spectrum in the CBRS band, which is just a huge block of spectrum capability and enables a tremendous capacity. In the 90s, when the cellular industry was really starting to take off, most national operators were building out networks with just 25 megahertz of spectrum. And now you're talking about something that's 5, 6 times more than that. So it's really tremendous capability. At the same time, the cost of LTE and now 5G radio technology has come down. The equipment has been miniaturized. The capacity per node has been increased. And so we think that's another really important innovation that now brings cellular technology into the realm of enterprise. But we think there's a couple of gaps yet to fill. And the first one is that we believe that these private enterprise networks can be better if interconnected to the cellular ecosystem. And so with our GeoCore platform, which is our hybrid cloud edge-based packet core technology, we have pre-integrated that with all the domestic carriers in the United States and around the world with many international operators as well. And that means that if your private radio network is served by the GeoCore platform, it is already pre-integrated with that entire cellular ecosystem, enabling the bilateral movement of devices. So if your private enterprise devices should need to access a public network, we can make that happen seamlessly. At the same time, GeoTrade is managing the business side of that relationship, right? If the private enterprise networks are going to be interconnected with the cellular ecosystem, we need a platform that's going to manage that relationship both commercially and from the service level. And so GeoTrade is a platform one of its primary purposes is to measure the customer experience that's being delivered on a private enterprise network. And by customer experience, I should probably just say device experience, because many of these end user devices are not going to be people. But the point is to measure the experience that those devices are having and being able to report that to the enterprise customer themselves, but also importantly to any other parties that may be utilizing that network in a neutral host fashion. So that's GeoCore and GeoTrade. And what we do with that is we would connect that to, a network design and customization that could be brought to you by Cambridge consultants, financed by Sentry. So in this example, we see, kind of a factory floor where you could have a diverse set of devices, many different types of sensors, robotics, and other remote controlled equipment that's all connected over the private cellular network. On top of that, we would then put our GeoCore infrastructure to provide the packet core networking capability that every LTE network requires, as well as to interconnect that with the outside ecosystem for bilateral movement of devices in and out of the private network. So again, our go-to-market is what we call network as a service, which is to combine our networking and operational support capabilities with the enterprise network that would be designed for you by Cambridge. We use the GeoCore network platform and the GeoTrade management platform to provide you with a fully interconnected private LTE or 5G network. I'd like to pause for just a couple of case studies of examples of where we have applied this. One that might be very relevant here is a partnership that we've had for nearly 10 years with the Navajo Tribal Utility Authority. The NTUA is a electrical and water utility that is owned by the Navajo Nation and was initially chartered to bring those services to people on the Navajo Nation in Arizona, Utah, and New Mexico. And we partnered with them to create NTUA Wireless, where we have been the operating partner, helping them transform from a electrical utility to adding communications, and particularly wireless communications to their business. And we've designed a variety of customized solutions for them. Anyway, the COVID crisis has been particularly acute for the Navajo. And so this year we've created a network of additional hotspots where people could come, pull up, and get internet access. We've deployed innovative plans to reduce the cost for teachers and students. We've worked with them to get grants to subsidize some of the hardware that's required in those programs. So it's just an example of where we've worked in a very collaborative way with our, in this case, utility partner to create solutions for their residents. Another example I might mention would be the job sites. So we have a customer that's in the construction business that is building a number of sports stadiums around the country, and they are using private cellular as the communications means on those job sites. And one of the primary reasons for that is security. Right? There have been cases where job site communication systems have been compromised. That's created real headaches for construction companies, caused delay and financial impact. And they wanted a communication system for push to talk, for a group call capability. They also use iPads to look at a lot of their CAD drawings. And so we've got cellular connected, CBRS connected iPads operating on the job site. So I think that's a very relevant example of where the performance advantages of cellular technology were appropriate for the application at the construction site. So to wrap up, just want to come back and focus on the operations and support capabilities from Geoverse, beginning with our carrier-grade network operations center that operates around the clock, around the year. We've got call center capabilities to be able to manage the interactions with your IT departments and help desks to support the products that are put in place, experts to provide tier 2 and 3 technical support. Above that, we maintain really tight relationships with nearly all the key vendors in this private cellular networking space. We can handle the proactive maintenance, patching, and upgrades that are required as time goes by. And we offer interoperability testing to pre-test devices with your network capabilities. And lastly, professional services, where we can, after the network is operational, continue to look at the optimization and expansion. So again, Geoverse is a really specialized cellular operator that focuses on providing customized solutions to enterprise customers, and we're really excited to be working with Cambridge and Sentry in putting together these solutions. Thank you. I think we're going to go now to Q&A.
Thank you. Yes, we will begin our question and answer time. There is still time to submit your questions using the Q&A tab to the left of your screen. We have lots of great questions already, and we will try to get to as many as possible. The first question, how is private cellular different to legacy approaches like Wi-Fi, carrier-provided LTE, or even 5G?
Yeah.
Colin, you want to take that first?
Yeah, sure. So I guess it comes down to the technology, and Wi-Fi is a bit like the Wild West. Anyone can shout and try and gain access, and you end up shouting over each other and just not being able to share the resources. Cellular technology is designed to be managed so that you can actually design it to meet your use case rather than just hope for the best. And I think that's the simplest solution, simplest answer from my point of view.
Yeah, and I think this is Jake speaking. I think from the business case itself, right? I mean, Wi-Fi has probably played its role in several solutions, but when you start to look at the carrier network itself and what's happening here, from, to be honest, some of the things that have happened within COVID and how much online shopping there's actually been, and warehousing logistics and how they actually have to scale, and from adding nodes to control to everything else that's happening within that facility, there's a lot left to be desired within those networks, and that's why companies are actually looking at ways of doing that. So Colin talked a little bit about the Wi-Fi side. I think from an M&O perspective, there's only so much that they can actually offer from their network. And that's why a lot of organizations are looking at building these private networks. And again, I urge everybody that has an opportunity to go ahead and look at the Ocado case study, because I think it gives a lot of good points as it relates to that type of scenario.
Yeah, and I would add, I mean, especially when you compare to potentially, let's say, using VPN over a standard cellular network as a way of creating a private cellular network. I mean, there you have, significant. I mean, the cellular networks are built for a general audience of business and consumer customers. With private cellular, you can tailor the coverage to your specific needs. You can tailor the capacity to your requirements. And, there's lots of subtleties here. For example, being able to optimize the mix of uplink traffic capacity versus downlink traffic capacity. With a private network, you get to set that based on the requirements of your applications. In a general cellular network, that has to be tuned to the average case. So lots of things that create a big difference between the capabilities of a private cellular network and standard cellular.
Yeah, and the last thing we'll add here too, and then we can go on to the next question is, I will say outside of a warehouse, potentially there's opportunities here, maybe in building could be there, but there's revenue opportunities for building these private cellular networks potentially, right? I think a lot of companies are looking at their specific application to build it against that application as a private network. But without a doubt, I think a lot of companies are looking at it as well as, could they actually make it a revenue stream? Could they build this in a public scenario? And again, this is all getting to the customization of that network and potentials that you have with it. So again, there's a lot of opportunity there as you start to move down and up the chain as it relates to getting that spectrum, and as well as building out on those private cellular networks.
Thank you. We will move on to the next question, which is, what is the biggest technical hurdle for developing a cellular solution in a warehouse automation system, and how do you overcome that?
So I think the biggest technical in automation is reliability. Because you're automating something, you need a highly reliable system. If it's indoors, if it's wireless in general, you're dealing with a propagation environment that makes it inherently unreliable. So you have to design that reliability in through redundancy in various ways, through, as Rod was mentioning earlier, looking at your traffic flows and optimizing exactly which direction you want to move the data in, where is the most capacity that you need. And it fundamentally comes down to what you're trying to do, what the information flows you actually need to occur, and what those priority and reliability levels are, to then focus in on those and design the solution that fits.
Yeah. And the only thing I'd probably add to that from the Cambridge side is to be able to take on not only the network, but as well as the end nodes, robotics, the AI. I mean, I think that's something that, the capability is there, but as well as, kind of understanding that net result and how everything can kind of work together beyond just the network itself, but all the nodes that are running on it. You can definitely see how that could be very complex and could be a major hurdle as you start to work on the density and everything else within that warehouse.
Thank you. For our next question, it is this. Regarding smart antennas to be directed to the area to cover, is it a mechanical feature to move mechanically antennas from one area to another, or is it from beamforming? Could you explain more?
So I think when I mentioned that, I was considering beamforming. That's active beamforming. And as Jake alluded to earlier, we just announced a project where we were involved in doing exactly that. But beamforming is part of the 5G standards, part of most standards now. It is the modern way of making sure that you can direct energy where you want. You combine that with other techniques like the dual transmission and dual reception, so you can actually effectively create spotlights of coverage in areas that you want, combining beamforming at various locations with distributed antennas as well. So it's definitely looking at the active beamforming rather than mechanical.
Thank you. The next question is, what is the penetration of a 5G signal through water?
Yeah. I feel like that's coming my way as well.
Yeah. I hope you have an answer, Colin, because that one I don't know.
Well, I think the answer is that 5G is like any other radio wave. The higher the frequency, the more it's going to struggle penetrating through water. So 5G operates from reasonably low frequencies, like 600 hertz range, up to sort of 30 or even higher gigahertz range. So the lower frequencies will go through fine, relatively fine, but the higher frequencies obviously won't. I don't think there are anything designed in specifically to deal with propagation through water, but if you think of it as range extension, then there are lots of things designed into LTE, not just the low frequency LTE 5G, the low frequencies, but also beamforming, as we mentioned, but narrow band signals, which inherently will travel further through very poor propagation environments. So the physics doesn't change, but some of the things that are included in 5G will help. It will still struggle, though.
And for the next question, what percentage of your customers relative to the hardware want to own the equipment at the end of the term of the financing term? And does the service provider hold title or typically transfer the title at the end of the term?
That's a great question. And so with virtually 100% of our financing structures, the customer either owns the equipment at the end or has the option to purchase the equipment at the end. And what we try to provide is the flexibility for the customer to either purchase it at the end of the financing term, to upgrade it and extend the lease term, or to extend the lease term or be done with it. And it depends a lot upon the customers, the accounting treatment they want, because if they own it, it's a CapEx expense, and if they have the option to buy it, if it's structured appropriately, it will be an OpEx expense. And so we hold title to the equipment through the lease term until the customer either buys it or extends.
Thank you. Another question. Besides the hardware, what else can be included in the financing? The software, the development, the design, the first year of Geoverse management?
Another great question. And as I mentioned earlier, the better the credit of the customer, the more flexibility that we have in the financing. And we do try to provide a holistic solution for the customer from a financing perspective. And that includes trying to include the design, the development, the software, the hardware, maybe a year or two of maintenance expenses, so that we're trying to provide a total solution for the customer on that.
Thank you. Another question. What benefits can custom private networks bring to my business versus standardized approaches?
Yeah, I think we've, just to go over a few of those, excuse me, I think firstly it is the customization capability to be able to, build a network that is specifically tailored to your coverage and capacity requirements, and tuned to the type of traffic that you need to carry, and it really kind of firewalled off from the rest of the cellular interference, so that you can really have the highly reliable capabilities that you would need for many of these applications. Maybe over to Colin or Jacob.
Yeah, I'll jump in there. You're exactly right, Rod. I mean, I think, there's been a lot of discussion, and as I stated in my presentation, where companies have looked at like LP-WAN and stuff like that for years. And the reason they have is that they want more control. They want to be able to own their own data, and they want to customize their network to their solutions and the requirements. And I think there's a lot of sacrifices that are made once you jump onto a public network, that sooner or later, as you start to scale into your 2 to 3.0 solutions, you realize that you really can't go much further in what you're trying to accomplish, and you're limited to what you're trying to accomplish within your innovation. And I think that's the main idea around here, is the fact that, you know, customization and innovation are equal. If you want to do this, innovation is a requirement in a lot of these applications. Now, mind you, there are applications out there where consumer off the shelves could potentially work, and the MNO network could get you by. But in other situations, there's things that go on. And I think of like the Tyson news release that they had out, where there was a pretty good amount of COVID positive tests within these meatpacking plants and cutting plants, and they brought robots in to cut them, and their complaint was the robots weren't as efficient, and et cetera. And that's a prime reason of running a private network within that solution. And then more importantly, being able to incorporate end nodes, AI, edge compute to improve that solution as you move forward. And you would not get a lot of that as you've moved into an MNO solution, let alone 5G, which we all know has a lot of issues with penetration within buildings. Colin, you want to add anything there?
I think you've covered it nicely, both of you. I think the answer is really in the flexibility and customization that you get. You know, a lot of people start out with Wi-Fi and then end up regretting that, because they get constrained and really shackled into working around problems that just don't exist when you come from a network that's designed for you.
One thing we didn't mention is security, that it might be worth coming back to. The cellular network standards have, you know, developed an end-to-end security and authentication model, which has proven itself, you know, across billions and billions of call attempts and hack attempts, you know, across all the cellular networks around the world. So it's really, you know, has a very hardened security and authentication capability, which, you know, in the case of our construction customer, that was one of the key considerations, right? You know, their network is out in the open, you know, it's a public construction area. They need to have very secure networks, and that was a driving factor in choosing private cellular over, you know, alternative solutions.
Yeah. I think that's right, Rod. And I'm seeing some of the questions here, and there's a lot of questions of security, and we apologize, we're not going to get to them all, but security is a major aspect of development, not only at the network level, but as well as the node and edge devices, right? And I think that's something, without a doubt, Cambridge takes on pretty seriously as it relates to the requirements per that application and what will transpire. So for all those asking questions about security, we'd love to talk to you more in depth about that. In future reference, reach out to us. It's more than we potentially could probably cover here in 5 minutes.
Yeah, I think building on that theme a little bit more, it's a lot that's built into cellular networks that are, in particular, mobility is another one where, you know, you don't have to make and break connections when you try moving between nodes. It's built in, baked into the standards, and as Rod has said, has been tried and tested, you know, through billions and billions of uses. Yep.
Thank you. Here is another question. How would Cambridge consultants and Geoverse typically run a project?
Well, I think that's probably multiple ways to do that, but I think we would be working together. Possibly Cambridge would prime the engagement and be responsible for helping the client to sort of visualize what the solution needs to do and accomplish, and we would be there to support the implementation, and operational support after the system goes live. But Jacob or Colin, maybe you should take that one first.
Yeah, I think, again, we have a process internally that goes from conceive to discovery development to support as we start to build these solutions out. Doesn't matter if it's private networking or et cetera. And within that, knowing there's a lot of customizability, and if we start to see there's opportunities for Geoverse to help out with the management side, without a doubt, we do engage them early and often to ensure the fact as we're building this out, they're aware of certain things that are potentially going on. Because again, what we're stating here is one size does not fit all. And I think that's where the engagement comes through, is to work with the organizations, get them engaged when we need to, and ensure the fact when this thing starts to roll out, it works exactly to what the customer is trying to accomplish. Excuse me. And more importantly, scales to where they're headed, right? And I think that's exactly how we'd engage. And again, we'd incorporate them into our current process of any development we do. Colin, anything you want to add?
I think you covered it nicely, Jay.
Perfect. I think we have time for maybe one more?
Yes, this will be our final question. We had a lot of great questions today and couldn't get to them all, but we will try our best to get back to everyone who submitted personally after the webinar. So here is our final question. Can financing include deposits, progress payments, or other amounts?
The simple answer to that question is absolutely. And again, we try to bring a financing solution to the table that is holistic, and it handles the whole thing and makes it easy for Cambridge and Geoverse and the customer. So yes.
Perfect.
Okay, so that was a clear answer. So we're actually going to do one more final question, and that is this. Cellular can be complex and costly to design and deploy. How can private cellular address these two critical things, and what approaches are out there?
Well, I can just say from the core network standpoint, and also from the hardware standpoint, I mean, these systems have become much less expensive than what might be typically thought of for cellular type equipment. So, in our GeoCore platform, we're operating much more of an enterprise scaled software platform than a carrier scaled software platform, and it's much more efficient. In fact, we've got nodes that can be installed on the enterprise premise to create an edge core solution. So I think that the fundamental technology is becoming much less expensive. Colin, Jacob?
Yeah, no, I agree with that. It's becoming much more available as well. So initiatives like Open RAN are making it possible for you to source common software components, and you only have to modify or create the components that you really need to. You don't need to start from scratch. So you're starting from a really, really good starting place with almost everything in place. And all you have to do is the bits that really make it fly for you.
Yeah, you covered that great, Colin. That's exactly right. I don't have anything else to add.
Well, with that, thank you for attending this Fierce Wireless webinar and submitting so many great questions. I'd like to thank our speakers for participating and Cambridge Consultants and Geoverse for presenting today's webinar. This webinar has been recorded. You will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you at future events.